Hey everybody, this is Larry. This is me trying to do the last of the weekly premium challenge for September 2023. Geez, saying it out loud is a little bit yikes. Apparently I've done this premium problem. Come on, give me a premium problem I haven't done before. But yeah, hit the like button, the subscribe button, join me in Discord, just checking for extra coins. Yeah, let me know what you think about today's premium weekly problem. Today's is 2393. Count strictly increasing subarrays. Did I do this during a contest or? I mean, this is a pretty thing, but let me check. I'm curious. December. I mean, it was a year ago. That's kind of weird that I've done this before. Do they just kind of make? I don't know. I'm still gonna try to do it, but I feel like, yeah, okay. So you're given an array nums of consisting of positive integers. We don't know the number of subarray nums that are strictly increasing order. Excuse me. A subarray is a contiguous part of an array. I think so. It's not quite, but I think the Q3 of the last weekly contest kind of had similar things to this problem. So that may be interesting. But the idea here, I mean, that was definitely which is kind of weird to say. That's a harder version of this nowadays. But the idea for this, or these kind of problems in general, is, and I kind of skipped ahead a little bit, or I, immediately jumped to it, is obviously look at n, the constraint, right? The constraint is 10 to the 5th, so you're not going to be able to do something n square, naive or whatever. I mean, if that's the case, then definitely do that, and then, don't look back and finish the problem in like 2 minutes or whatever, right? Do your 2 for loops. But this one, given an n is 10 to the 5th, you're not going to be able to do it in n squared time. So you have to be a little bit faster. And here, there are a couple of ways you can kind of think about it visually. The way that I like to think about is, for each element, figure out how do I calculate the contribution to the answer, right? And there are kind of variations of this problem, asking you for different things, where you have to get the sum of, certain number of subarrays or whatever. And of course, in this particular case, this is subarray, not subsequence. The idea, the high level idea is going to be very similar, just because, the idea of for each element, figure out the contribution, so that you can kind of do it in a faster time, right? Because basically, if you do it naive, it's going to take O of n, and if each element takes O of n time, then that's how you get n squared. So each element has to be at least amortized faster than O of n. Log n is fine. Log of O of 1 even better, depending on the problem. Might not be possible, but yeah. Okay, so for this one, I'm just gonna take a look at, for example, here, right? Oops. And what are we doing? So yeah. So then the idea for this one actually it's a different one that I'm thinking of, but that's fine. But for each number, and there are a couple of ways to do contribution, as I mentioned. I think sometimes you want to look to the left and to the right, and sometimes only look at one direction, so you don't double count. So the way that there are a couple, and only practice probably. I mean, you can feel it out, and maybe there's a better rule set. But at the end of the day, if you're going to run into all these different type of problems, you want to be able to practice all these problems, and all these practice will allow you to get them in a quicker way. And for this one, the way that I like to think about it is, for each number, figure out how many ways is there to have this as the last element of your subarray. I think that's the way to say it. The reason why it's a very awkward saying, but phrased that way, is so that you don't double count, right? Because let's say, I don't know, let's just say, strictly increasing is this one. But yeah, let's say this is 3, right? So 3, what subarrays is in 3, right? Well, it's going to be 3 just by itself, 1 and 3, 1, 3, 5, and then 3 and 5, right? The thing is that, if you kind of just list out 3 like this as 4 contribution, which is fine, but it's you have to figure out a way to not double count it, right? Because now let's say we look at only 5s, right? So then now 5s, 5 are 5, we have 3 5, we have 1 3 5, right, and so forth. So now, as you can see, we do 1 3 5, 1 3 5, 3 5 in the same way, and there are a couple of techniques, or like, when you practice, there are a couple of observations, really. They're not like, I hesitate to say technique just because it feels like something you have to memorize, and I hope you don't. For me, it's something that you just kind of make an observation on, and then it becomes something that you notice happens a few times in different places. And that idea, that observation is that to kind of dedupe this is to kind of, for each number, think about it as basically the rightmost element subarray, right? So then now, almost like another way you can kind of think about it is, for every subarray, give me a representative example or representative element, right? And in this case, this is 3, this is also 3, so this is 5, this is 5, and this is 5 5 5, right? So then now you only count the representative by the thing, then you'll never double count. So that's basically the idea, right? And in this particular problem, so then we have to just count it that way. But in this one actually is not that difficult one, because you only have strictly increasing subarray. So then now we can just say, for x in nums, right? So maybe I do the previous number as well. Previous is equal to 0, or maybe, is it 0? Yeah, maybe just call it infinity, actually. I think that's a better sentinel. And let's actually name this a little bit longer. And then maybe the streak is equal to 0. And the other thing I want to say is that, and we're right there pretty much, is that with these problems, with subarray particularly, you want to kind of count the degrees of freedom, right? And here, if you have to, in a brute force kind of way, you may go to the left n times, and that'll be n squared. So now, looking backwards, is another way to say is, when does this, how far left can you go, right? Is what you're really asking for each element. And now, if you could do that in faster than O of n time, then that's great, right? So that's basically the idea. And for this one, for example, for the 5, you have a couple of degrees of freedom, because you can go 5, you can go 3 5, you go 1 3 5, right? To kind of go to the left twice, or 3 degrees of freedom, depending on how you want to say it. I actually don't remember. This is, it's a very technical term with a specific definition. I forget if I'm off by one about it, maybe, possibly. So definitely look that up. But yeah. So then now, if x is greater than previous, it has to be strictly. Then we increase the streak. Previous equal to x, and then also the current streak now is the number of subarrays that you have, it turns out, right? So you could do something like this. Else streak is equal to 1, previous is equal to x. I guess this part doesn't change, so we can actually take it out, right? Also, this doesn't change, so maybe we could take that out as well, right? And that should be it, unless I'm off by one something, because I don't know. Yeah, very simple code, to be frank, and actually simpler than I actually expected to be. Also, to be honest, that I don't mean to suggest this is easy, especially if you haven't done it before. But the code is pretty. But yeah, I think that's also one thing that I would also caution a little bit about, is that sometimes you look up the solution, and I hope you at least gave it a good attempt before coming here. But you look up the solution, it's like, oh yeah, this is 10 lines, or 10, 12 lines of code, and most of the code is just like, this thing, which I don't even count, but like, and it's easy to look at that and be like, oh yeah, of course, but there are a lot of deceptive, in the sense that, like, you still have to build out that fundamental, you still have to build out that foundations to really get to a point where you can write this code from scratch and not just like remember bits and pieces, and then that's how you confuse yourself a lot. And I think this happens to me still even nowadays, because sometimes I'm like, oh, I know this is thing, but then I'm like, oh, now you don't, you didn't really actually learn it, you forgot like a few things, right? So that happens quite a bit as well. So yeah, anyway, that's all I have for this one. Let me know what you think. Yeah, stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.